Hello, and welcome to 10 more interesting problems on polynomials and quadratic equations. So first we get 498 out of the way. Now the link to download the PDF will be in description, and I will show you at the end how to download the PDF. And as always, I will say that when I'm stating the problem, you should pause the video and try to solve the problem yourself. If you cannot solve the problem yourself, only then look at the solution. We did not solve 498 because of typing issues. So I fixed that and we will solve question 498. So question 498 says that 2 to the power x minus 1 dot 27 to the power x by x plus 2 is equal to 3. So we look at the solution. We have this given. We take log with base 2. So this will become x minus 1 plus this would be 3 to the power 3, that is 3x by x plus 2. And this 3 will come from that side, so it will be minus 1. This power will go as the coefficient, that is 3x by x plus 2 into 3 log of 3 with base 2. And this log 3 with base 2 will be subtracted. So it will become 2x minus 2 by x plus 2. Once we have that, what we do is we write x minus 1 plus minus, we subtract 2x minus 2 x plus 2. So this subtraction means we have to also add 1 to this. So we add 1 here. That is what we add, log 2 with base 2. So this becomes log 6. So our entire equation becomes x square minus x, you take LCM here, by x plus 2 plus 2x minus 2 by x plus 2 log 6. Once we have that, we take x minus 1 by x plus 2 common, and we get x plus log 6 with base 2. So you need to do the simplification here. Now if you look at this, you can send all x plus 2 right to the 0. Okay. Now if you take x minus 1 common here, alright, then what will happen? What will remain here is x. Okay, and from here you take x minus 1, then it will be 2. So there should be a 2 here. 2 is missing. So x will have two values now, 1 and log of 6. And minus 2 is multiplied with that. Now we come to the problems of this set, that is question 501. Says solve log of 6x square plus 23x plus 21 with base 2x plus 3 is equal to 4 minus log of 4x square plus 12x plus 9 and base is 3x plus 7. So we are given this, alright. So left hand side we split into two fractions, that is 2x plus 3 into 3x plus 7. And the right hand side, the equation inside brackets, that is 4x square plus 12x plus 9 becomes 2x plus 3 whole square. Now if you look at left hand side, it will become 1 plus log of 3x plus 7 by 2x plus 3, because log of 2x plus 3 with the same base would be 1. And right hand side we bring 2 to the coefficient, which becomes 4 minus 2 log of 2x plus 3 with base 3x plus 7. Now on the left hand side we bring this to left hand side, and it becomes log of 3x plus 7 with base 2x plus 3 minus log of 2x plus 3 with base 3x plus 7. Okay, so there is something wrong here. There should be a 2 here, 2 is missing, 2 should be multiplied. Okay, now we let log of 3x plus 7 with base 2x plus 3 is equal to z. Then we exchange the base and number, and we have log of 2x plus 3 with base 3x plus 7 is equal to z. You see 2 here, this 2 was there. Okay, so and this minus should become plus here. So there are two typing mistakes. So we have z plus 2 by z is equal to 3. That means z is equal to 1 and 2. It becomes z square plus 2 by z is equal to 3. So z square minus 3z plus 2 is equal to 0. So z is equal to 1, 2. That implies that 2x plus 3 is equal to 3x plus 7 is equal, which implies that when z is equal to 1, which implies that x is equal to minus 4, which is not possible because 2x plus 3 has to be greater than 0. When z is equal to 2, 3x plus 7 is equal to 2x plus 3 whole square. So which gives x is equal to minus 1 by 4 and minus 2. But again, x is equal to minus 2 is not possible because it will make 2x plus 3 less than 0. So the only possible solution is x is equal to minus 4. So 498 and 501 have typing mistakes. This should be plus 2 here. There should be a plus 2. Okay. And in 498, we should have, what was the typing mistake here? 498, I forgot what was the typing mistake here. Okay, there should be 2 here. Okay, 2 here and plus 2 here. All right. I'm trying to mark this mentally so that I can fix it. Question 502 says that prove that 2x to the power 4 plus 1402 minus y to the power 4 has no integral solution. So we rewrite this as y to the power 4 minus 2x to the power 4 is equal to 1402. So we get y to the power y square plus square root of 2. This should be whole. No, this shouldn't be whole square. Root 2 x square into y square minus square root of 2x square. That is equal to 701 minus 2. Now since x y are integers, so because we want integral solutions, so x square and y square both are greater than 0, which implies that y square plus square root of 2x square is equal to 701 and y square minus square root of 2x square is equal to 2. Now we add this. Note that 701 is a prime number, I believe. Let me quickly verify that. So 676 is square of 26 and 27 is 729. So we should divide up to 26. So it is not divisible by 2, it is not divisible by 3, it is not divisible by 5, not by 7, not by 11, not by 13, no. 17, no. And then we have 19. No, it is not divisible by 19. Let's say try 23. It is not divisible by 23. And then it has no prime factor. It is a prime number, okay? And 2 is also a prime number. And 703, I believe, would be a prime number, okay? Now, it doesn't matter if it's prime or not. If y square is equal to 703 and 2 is here, it will go and it will make it a fraction. It will not be an integer anymore. It doesn't matter. We don't need to calculate prime and all for this. Question 503 says that we need to solve for x, where mod x minus 1 to the power log x square with base 3 minus 2 into log of 9 with base x is equal to x minus 1 to the power 7. So given equation is this. So clearly x is greater than 1 for log x with base 9 to be defined. Okay. So now the equation becomes x minus 1 to the power log x square with base 3 minus 2 log 9 with base x is equal to x minus 1 to the power 7. Okay. Let us ponder here for a bit that why x should be greater than 1. Okay. Now bases can be between 0 and 1. Alright. Now what will happen is this quantity, it doesn't matter, it is positive or negative. Okay. It is a mod, so it will be positive, and positive to the power anything will be positive. Okay. Whether it turns out to be positive or negative. But right hand side, if you see, if x is less than 1, then it will become negative. So we don't want that. It has to be greater than 1 so that it remains positive. And that's why we arrived at this conclusion. Okay. Now, once we have this, what we do is we take log of both sides. Okay. So this power can be written as 2 into log of x with base 3 minus 4 into log of 3 with base x minus 7. 7 will come from this side, and inside we will have log x minus 1, or rather the multiplication of log x minus 1, okay, is equal to 0. It doesn't need to be in bracket. Now once we have this, we see that this and this are reciprocal. Okay, so we take this as z, we split this into two parts. So one part is this, one part is this. So from log x minus 1 is equal to 0, we get x is equal to 2. And we take log of x with base 3 as z, so this would be 1 by z. So the equation will become 2z square minus 7z minus 4 is equal to 0. So z is equal to 4 and minus half. Clearly minus half is ruled out because x will become 1 by square root 3, so x is equal to 81 here. So 81 is the second solution. We have two solutions, x is equal to 2 and x is equal to 81. Now we solve question 504. Solve cos x to the power sine square x minus 3 by 2 sin x plus half is equal to 1. So clearly one of the solution is that you make cos x is equal to 1. So which makes that exponent doesn't matter anymore, okay? So x is equal to 2 and pi for our first solution. It is unnecessary to write this, but all right. The second solution, for the second solution, we equate the powers. So sin square x minus 3 by 2 sin x plus half is equal to 0. So if we make this 0 power 0, cos x to the power 0 will be always 1. Now it gives sin x is equal to 1 and half. But if sin x is equal to 1, then cos x is equal to 0, which makes the equation invalid. That should be E. Therefore, sin x is equal to half, and sin x is equal to half is equal to sin x is equal to half is our second solution, which gives x is equal to n pi plus minus 1 to the power n pi by 6 when n is in the set of integers. Now this requires a bit of trigonometry. If you don't know trigonometry, then you can download my book on trigonometry, which I'll show at the end, and study this problem. Question 505 says that find the integral values of a for which the equation x plus a into x plus 1991 plus 1 is equal to 0 has integral roots. So we are given this equation, we write this as x plus a into x plus 1991. Now note that we want integral roots, that means integral values of a, okay, for which the equation should have integral roots. So a and x both are integers. Now, if this is the case, then we'll let x plus a is equal to 1 and x plus 1991 is equal to minus 1. So, which will give a is equal to 1993 because x will be 1992. The other possibility is x plus a is equal to minus 1 and x plus 1991 is equal to 1. So, this will give a is equal to 1989. Very easy problem. Question 506 says that solve 2 to the power sine square x plus 5 into 2 to the power cos square x is equal to 7. So we write the given equation as 2 to the power sine square x plus 10 by sine square x. How this came is you write cos square x as 1 minus sine square x. So it will become 5 into 2 by 2 sine 2 to the power sine square x. This should be 2 to the power sine square x. Okay. We let 2 to the power sine square x is equal to y, so the equation becomes y plus 10 by y is equal to 7. So we get y square minus 7y plus 10 is equal to 0, so y is equal to 2 and 5. Now we make y is equal to 5, which makes sine square x greater than 1, which is not possible. Now if y is equal to 2, then sine x is equal to plus minus 1, so our x is n pi plus minus 1 to the power n into plus minus pi by 2. Question 507 says that solve x plus log of 1 plus 2 to the power x with base 10 is equal to x into log 5 with base 10 plus log of 6 with base 10. So we are given that x plus log of 1 plus 2 to the power x with base 10 is equal to x log 5 with base 10 plus x log 6 with base 10. So what we do here is we take x common from this, okay? Now this we take this and we bring it to left hand side. It becomes x into 1 minus log 5 with base 10. And then we have log 10, log of 1 plus 2 to the power x with base 10 is equal to log 6 with base 10. So what we do is we write this one as log of 10 with base 10. This should be 10, okay? And we proceed, so this will become log of 2. So x log of 2 with base 10 plus log 1 plus 2 to the power x with base 10 is equal to log 6 by 10. Now this you can write as 2 to the power x, and the entire thing on the left hand side becomes, upon taking into log, 2 to the power x into 1 plus 2 to the power x is equal to 6. So 2 to the power x is equal to 2 and minus 3. because these are integers. So if you look at this 407, okay, this 6 is 2 and minus 3, and if 2 to power x is if x is irrational or a fraction, then it won't give integer solutions for this. So we take x as integers, and 2 to power x is equal to 2 and minus 3, but x 2 to power x cannot be minus 3. So x is equal to 2, and we have x is equal to 1. Question 508 says that if a greater than 0, solve the equation log of ax with base a into log of ax with base x plus log of a with base a square is equal to 0. So we have to solve this equation. So what we do is we split the terms. We get for the first one log of x with base a, and for the second one we get log of a with base x, and the third one becomes half because this a square will give half and base will become a. Log of a with base a is 1, so it is half. Once we have that, we can write this as log of x with base a whole square. Okay, and note that this log of ax can be written as log of x with base a. So that's what we have done. Okay, now this after that, this equation becomes 2 into log of x with base a whole square plus 5 log of x with base a plus 2 is equal to 0. And then you simply solve it. You arrive at these two solutions. Question 509 says that solve square root of 11 minus 6 plus square root of x minus 1 is equal to square root of 4x plus 5. So we square once, we arrive at this equation, and then you bring everything to one side and then you square again, and you obtain the equation 5x square minus 31x plus 30 is equal to 0, which gives x is equal to 6 by 5 and 5. But if you put x is equal to 5 here, it won't satisfy the equation. Okay, so that is an extraneous root, and it comes from the squaring. When you square the equation, extra roots will be introduced. Okay, so if you put x is equal to 6 by 5, you will have a solution. Now we solve question 510, which is the last question of the set. Solve square root of 3x square minus 7x minus 30 minus square root of 2x square minus 7x minus 5 is equal to x minus 5. So like previous problem, we square once, we bring everything to one side, and then we square again. There is no need to square again. So upon squaring it once, we will be left with x minus 5 into 5 minus square root of 2x square minus 7x minus 5. So x is equal to 5 is one of the solutions. So we square again here later by putting 5 is equal to square root of 2x square minus 7x minus 5, and we get 2x square minus 7x minus 30. X is equal to 6 and minus 5 by 2 are two roots of this, but x is equal to minus 5 by 2 will not satisfy the equation, so 5 and 6 are the solution. So with this, we come to the end of 51st set of problems. Not many problems are remaining. 554 if I remember. So in 554 means 5 more videos. Or what I will do is, let me quickly check 554, right? So 44 more questions, right? 44 more questions. What I will do is from the next set is that we will solve 11 questions, okay? So from here, we will solve 11 questions, and in 4 days, we will finish theory of equations and polynomials. So I hope that you are enjoying this and finding the problems interesting. To download the PDF, come to stock.org. Look at the second link, click it. Last updated date is 4th April, and you can also download the trigonometry book. Go ahead and read ahead of the videos. Don't wait for me to make the programs. The dates indicate when the file is updated. So we had quite a few typing mistakes, and I'll fix this and update the PDF. So with that, I will end the video. Thanks a lot for watching the video, and keep solving problems. Enjoy.